graph itself represents a zero state at the line. Anything above the line gets bigger than zero. Below the line gets littler than zero. Every time you're going to start at zero and end at zero. Start at zero, end at zero. And then you're going to do exactly what the picture tells you to do. The picture says, in my case, to go up 78.75. It tells you to go down 500 pounds a foot for 4 feet. The little arrow's pointing down. So I have $7,875 in my wallet. I'm going to spend $500 a day. At the end of 4 days, how much do I have left? It's exactly what you're doing. So I'm going to spend $2 grand. 58.75, then I drop 2,500. So I go 2,500, 58.75. 58.75 minus 2,500, 33.75. Then I'm going to drop another 2,000, 4 more days, so I'm down to 13.75. Then I'm going to take 13.75 and I'm going to subtract 3,000 from it, and I end up with minus 16.25. Drop 2,000 more. Drop 2,000 more. Drop 2,000 more. Go back up. And if I did it right, I should back to zero. Connect the dots. Moving at a constant rate. A line that represents a downward movement at a constant rate is a sloped line. So I'm going to connect these with a straight line, down, straight line, down, straight line, down, straight line, up. There's my shear diagram. Shear diagram closed. I need the areas of that diagram to calculate and figure out the moments directly below. So, moments. This is a statement you got to understand. Hopefully you got it from the videos. The change in moment between any two of these vertical lines is equal to the area directly above it. Okay? So if I know the area above, I know the change in moment. So I figure those areas. Hopefully you can find the area of a trapezoid. I do it by adding up the heights, dividing by 2, and multiplying by the width. 7,875 plus 5,875 divided by 2 times 4. 27.5. That doesn't look too good. I'm going to put it in something else. 27.5. Area of that one, that is in foot-pounds. 33.75 plus 13.75 divided by 2 times 4. 9,500. 16.25. 36.25 added together divided by 2 multiplied by 4. 10.5. And 56.25. 76.25 divided by 2 times 4. 26.5. Okay, I know the change between vertical lines. I do this. You won't, because for some reason you guys don't think you need to. I need to. I'm going to add the areas above the line and the areas below the line and see if they're equal. So my sum of my pluses, 27.5, 9,500, 0, 0, 0, 7, 37,000, sum of my minuses, 10.5, 26.5, 0, 0, 0, carry 1, 7, 37,000. They match, which is perfect. Now I can plot the moment diagram below. Now I've got one of my numbers right now. The biggest absolute value on this picture fills in that V. It's V max. So I've got 78, 58, 76. There's the biggest number on that picture. So I can wander over and I can put 78, 75 where that V is. So I'm going to do that. 7, 8. No, that doesn't work too well. Seven, 8, 7, 5. Goes right there. That's right off of the shear diagram. That one's ready to calculate. Now I got to draw a moment diagram. Remember what I just said. The change in moment between any two lines is the area directly above it. Start at 0. The change in moment between that line and that line is 27.5 positive, plus 27.5. The change in moment between this line and this line is plus 95. 95 plus this gives me 37,000. Change in moment between this line and this line is that. Minus 10.5. And change in moment between that line and that line is that, back to 0. Okay, we got a shape that has no definition. Got dots. Got to fill in the distances between the dots. To do that, look at the picture. If I divided that into 4 1-foot widths, the areas keep getting smaller. Something that's getting bigger at a smaller rate is a curve that looks like this, increasing at a decreasing rate. Parabola. Same thing's happening over here. Increasing at a decreasing rate. 4 foot on this side. 1, 2. The areas keep getting bigger from left to right. They're getting bigger, smaller, getting smaller at a faster rate. Decreasing at an increasing rate. Start out slow and become fast. Same thing here. Slow, become fast. So there's the shape of the moment diagram.